Welcome back, ladies and gentlemen. So obviously we have finished up with acceleration. Quite a few people have attempted the quiz already. Some of them have even managed to catch some errors that I made, so thank you for everyone who did that. For those who haven't gotten to it yet, don't worry, you've got time. In the meantime, though, I'm going to continue on from acceleration. We have now basically covered all of the different topics in the first part of physics, where we sort of covered, distance, displacement, time, mass, distance, already did distance, velocity, speed, acceleration. We got all of these different terms. But way at the start of this whole thing, I ended up telling you guys that physics can be represented in a lot of ways. You can show it with words, like our notes. You can show it with pictures, like you see here. You can show it with formulas, like you saw when we did these very calculations. And you can also show it with a graph. Now, you guys have been working on graphing since about grade 7. Some of you even kind of know why. Some of you maybe not. So we're going to take a moment here to talk about the purpose of graphing. What is graphing for? What does it do? How does it work? And how can you make it work for you? Because at the end of the day, graphing is a tool. Its purpose is to make things easier. I know it doesn't seem like that because, it seems like it's an awful lot of work, but this usually happens in life, that the more you know, the easier certain things become. You put in a lot of initial work to get to that level of knowledge, but then you get to kind of just find a whole bunch of stuff that's underneath that level of knowledge just becomes pretty simple. Very simple example. At one point, getting from here to the other side of the room when you were a tiny little toddler was very hard. But now you just walk. You know how to walk, so it's easy. You just go there. Learning how to walk took an awful lot of effort. You fell over a lot. It was very adorable. I'm sure your parents will tell you. But now that you know how to do it, everything else becomes easy. Anyway, graphing. So, graphing, the purpose of graphing. Now, what I'm about to say is basically going to be taken from your notes. This particular little discussion, this lecture, if you will, I originally came up with it on the spot several years ago now, and I decided to write it all down with some nice pictures and stuff. So what you're going to see here up on the board is me just sort of explaining things that are already in your notes. You're welcome to skip ahead in the video if you want, or if you want to hang out so I can continue to explain wonderful little side stories about how you used to be a baby or something, then we can do that too. Either way, your call. So, page 32 is the page that I'm going to be talking about here, and it's called the purpose of graphing. Now, the starting point is the example of consider a person pacing back and forth, right? So moving back and forth. Consider a person pacing back and forth along the same dimension. What's a dimension? Remember, it's a pair of opposite directions. I wonder if I remembered to tell you guys that earlier. Doesn't really matter. If I didn't, I'll tell you now. A dimension is a pair of opposite directions. So, for example, here is a ruler. The ruler, if we put a mark in the middle at 50, has got a left and a right. This is a dimension because there is a left and a right direction to that dimension. There is also another dimension that you inhabit, up and down. I know, very complicated. And then there is a third dimension towards the screen, camera U, and away from the screen, camera U, towards the board. These are the three dimensions that you live in your everyday life all the time. This is also why a 3D movie is called a 3D movie, right? Because there are two dimensions, the length of the screen and the height of the screen, and then the third dimension that they charge extra for is that whole part that's popping out towards you. Anyway, total aside. Consider a person pacing back and forth. Dimension talk off to the side here. We just got a person pacing back and forth. Well, if I draw them pacing back and forth, it's going to be really hard to see, right? Because I'm going to start off with something like this. Okay, so I start here, and then I'm going to go up, and then I'm going to come down, and then I'm going to go up some more, and then I go down, and then I go up. Maybe I stay still, then I go down again. And that doesn't look like anything. It's just a bunch of lines on top of each other. Sure, if you were to play back the video slowly while watching me draw it and listening to what I'm saying, you could get a picture of it, but by itself, that's going to be a pain. So we don't do that. We don't draw pictures like this when we're talking about things, even though it's, technically accurate. I'm moving back and forth along the same dimension. Instead, what we do is that we space out the arrows. So the example here that I've got on page 32 is that I start here, so I'm just going to cut this off here. So this is example 1. This is going to be example 2. Okay, so there we go. So I'm going to start here, and we're going to go up. It says here 10. Now we're going to come down 5. See how we're spacing them out going this way? Then we go up from here, 15. And then we're going to just stay perfectly still. So I'm going to mark that with a little line that's flat. And then I'm going to come back down again. And how far did I choose in my notes, Rich? I said 20. Very convenient number. And then I said we go up another 5. Right? So, broadly speaking, this is showing the same basic information as this, but this is way easier to see than this one, right? This is a picture that is simpler to understand. Now, that's kind of what we do with all of this stuff. We're trying to make stuff simpler, easier to understand. Now, here's the thing. If you kind of look at this information is already almost a graph, right? This is the distance we traveled. And then this, well, how did I space out these things? Why did I put each line separately? Because each line is happening at a different time. Now, if I want to get technical with fancy words, I would say that this is a two-dimensional analysis. 2 dimensions, in this case, being up and down and left and right. If I wanted to be less fancy, I would say I'm studying this problem both up and down and left and right. That also explains it. Now, we can do a little more, right? We can make a graph out of this, and you guys have made graphs before, so you know how to do it. But a reminder, we're going to have time, and we're going to have position. Okay, there we go. It's x, x, then y. Okay? So, well, what's our starting time? Well, we're going to need some numbers for that. So I ended up saying some times in the diagrams. I'll put the times in green, just to make it a little easier to see. So I said that this one here was going to be 10 seconds. And this one was going to be 5 seconds. And then the next one here was going to be 15 seconds. Man, it's almost like I took really simple numbers because it was an example or something. 5 seconds. And then the 20, I wonder if it's 20 seconds. Oh, it's not. It's 5 seconds. Oh, I had to throw a curveball in there at some point. And then the last 5 meters was also in 5 seconds. So there we go. We got all the information. So now we fill it in. So we start off at time 0. Very simple. Well, if there's time 0, what's our position? I'll do that in red. What's our position? Well, remember, position is measured from a reference point, and we get to decide where the reference point is. So why don't we make the reference point where we started? That way it's nice and easy. So this is going to be 0. There we go. Then what happens? Okay, we look at our first vector, our first arrow, and we go 10 seconds, right, because that's what it says, and we go 10 meters. Okay, so that's pretty straightforward. We started at 0, and we're going to go 10 meters. Now, I guess we should put some units on this graph just to make sure we remember what's going on. So that was going to be seconds, and that was going to be meters. Okay? Okay, sweet. So then the next one was 5 seconds, and it's 5 meters. Okay, so people who aren't paying attention will do this. Okay, so then 5 seconds, and we will be 5 meters. What's wrong with this? Do you know many clocks that start counting randomly like that? Right, 5 seconds. It's not 5 seconds from when we started the clock. Right, we started our stopwatch, click, and it counts up. And it counts up for 10 seconds. Well, it keeps counting. It doesn't just like reset to 0 and then start over. So this number here isn't 5. This number here should be 15. Now, is this number 5? Well, yes, it is, because this was 5 going down. So we went up 10, down 5, number line type stuff. That means that we're at 5. Okay, well, that's not bad. And the next one, 15. Okay, now again, I don't put 15 here. I add the 15 to the existing number, so I'm going to get 30. Now I'm going to go up 15. I don't just put 15 here because I'm not starting at 0, right? See, I'm here. I'm not down here. I'm here. So I'm going up from there. So that means this is going to be 20, right? Because I'm adding 5 to 20, right? Remember, again, number line kind of stuff here, right? So if we draw a number line, right, real quick here, I was here at 5, and then I'm going to add 15. So then I go, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm up here, right? And that will be 20. Right? Just very simple number line stuff. We just have to remind ourselves how it works because it's probably been a while. Okay, so there we go. We got 30, we got 15, and then what? Oh, 5 seconds. Okay, so another 5 seconds. That means this is 35. And then what happens? Right, up here. What happens? Nothing. We stay exactly in the same place. We don't move in any way. So that means this is still 20. Okay, then another 5 seconds. Well, 5 more seconds would be 40. And we move 20. Well, we were at 20, and we're moving 20 down. So where do we end up? It's number line stuff again. We're way over here 20, and then we're going to go 20 steps back. Well, we're at 0 again. And then in the last 5 seconds, so this will be 45, we are now up to position 5. There we go. This is a table of data. So this is a table. So we've collected our information. Awesome. Now what? What does it do for us? Because you told me, you are saying to me, at your screen right now, because you're so passionate about physics, you told me, Mr. C, that this was to make my life easier, and this doesn't look easy. There's like arrows everywhere, there are numbers, you got 3 different colors going on, it's a total mess. So what are we missing? What do we have to do? Well, now we have to actually make our graph. We do that over here. So we'll do a quick sketch of a graph. We're going to have time down here. Now the biggest number we get is 45. Okay, so I'm going to put 50 over here because that's the biggest. And over here is going to be 0, and right in the middle here is going to be 25. Right? Makes it simple for us. Okay? And then we're going to break each of these up. So we're going to get like 5, 10, 15, 20. It's about right. Let's just space it a little bit better. 5, 10, 15, 20. There we go. And then over here, 5, 10, 15, 20. And I hear you go, but it wasn't 20 over there, Mr. C. This is supposed to be 45s and stuff. Yeah, I know, but there's some same amount of lines between here and here, right? All right, meanwhile, we do the position going up. The biggest number we get is 20. So this is going to be 0. And up here, I'm just going to make that 20 to make it easy. It's at the top. And then here, I'm going to make that 10. And this is going to be 15. And this is going to be 5. Cutting things in halves are a lot easier. That's kind of why I chose this one way over here to be 50, because then 25 is easy. If I made this 45, which is what the actual biggest time was, it doesn't get easy to cut it in half anymore. So there's a bit of a trick for you. You're making a graph, try to see if you can cut it in halves. Okay, now we're going to graph our points. I'm going to use a different color because I have them, so why not? So when you're starting off, we're at 0, 0. So we put a little point right there like so. Boom, done. Then at 10, so 5, 10, we are at 10. So that's up here. 15, which would be this, we're at 5. So we came back down a bit, put it right there. And then at 30, we're at 20. Okay, so here's 25, 30. We're up at 20. So I got to go way up there. Then I stay at that for another 5 seconds, so 35. So there's, 25, 30, 35. So I'm staying up there. And then I drop all the way down to 0 right here. And then finally I come back up to 5 right there. Okay, so there, we've got a graph. Everything's done now, right? Everything's much better. We look at that and go, oh, yes, that's very clear, Mr. C. I understand that perfectly. Yeah, you probably don't. And there's a reason for that. We're not done. There's two things to see here. First of all, again, the purpose of a graph is to make things easier to understand. Now, the key is to make it easier to understand for humans, which I assume you are because none of you admitted to being space aliens yet. Humans have got these wonderful eyes, and our eyes are very good at picking up visual information, as they call it, seeing things. There's a saying in English, a picture is worth 1,000 words. There's a reason for that. Humans can see something and immediately understand what it means. Machines, computers, they can't, right? Computers are terrible at pictures, right? If you guys have ever had to do that whole prove you are human thing, well, what they're trying to do is they're trying to see if you are a bot, an AI, some sort of device that's being programmed that's going to cause havoc on their site, because it's very easy for a bot to work on the internet, sort of their natural home in some ways, but they suck at pictures. All those times you have to prove that you're human, and they're doing stuff like identify traffic lights and fire hydrants. You guys are basically training bots on how to identify those things. You guys are sort of providing the answer key to a test for the bots. Because you can very quickly go, well, that's a fire hydrant, that's a traffic light, whereas a bot goes, I don't know what that is. Could be anything. What bots are really good at is numbers, right? This table of numbers here that we've already done. A bot is great at tables of numbers, right? You may have seen Excel where people can put numbers in. Like this is a pretty short table, right? It only goes up down to here. But sometimes a table of numbers can be millions of lines long. Literally millions. And if you give millions and millions of numbers to a person and say, quick, find the pattern in this, people go, I don't know. And that's normal. That's how people work. If you give that to a computer and say, find the pattern in this, they'll be like, on it, boss. Right? That's what computer modeling is. That's what, computer games work on. But if you give people a picture, they can understand it real quick. Now, the problem is that our picture here isn't finished. Right? I've got data points on it, but that's not very clear. It's hard to follow. Our eye doesn't work well with individual dots. So what do? We connect the dots. I take out my trusty ruler here, because Mr. C cannot draw a straight line to save his life. And I go 1, 2, 3, 4, 5, 6. And now that is a lot easier to see. That graph gives us a very strong indication of the trend. We can spot key patterns very easily. And here's the wonderful thing about graphs, right? This graph is only a few points, right? 1, 2, 3, 4, 5, 6, 7. 7 points. Nothing fancy. But if this graph was 1 million data points, it would still be just as resolvable. It's just as easy to see. I mean, depending on how much you guys have been watching the news, you will have been seeing a lot of graphs because they do graphs about this pandemic that we're dealing with. They do that for a reason. Numbers, millions of people sick, it's hard to understand. But a graph with a line, is the line going up? Is it going down? Is it flattening out? Have we flattened the curve? You may have heard these things. This is all talk about graphs because this is something we can understand, right? If, hypothetically speaking, this was our current pandemic graph, what we would see is that the number of sick people went up really sharply, and then it dipped. Why did it go down? What happened? Oh, did some of the people die? That might be it. Here, it went up again, and then it flattened. This would be what they meant by flattening the curve. That means that there are no more infections. Now, obviously, this graph here wasn't originally designed with the pandemic in mind. I just made this up a couple years ago now. So this isn't really what the graph would look like for the pandemic, but it's the same idea, right? We can see if there are trends or patterns in the numbers by quickly glancing at that picture, right? If I cover up the graph and just say, hey, quick, find a pattern. You can do that a lot easier than if I cover up a bunch of numbers, reveal them and go, quick, what's the pattern? You'll be like, I don't know. So that said, right, I've had many, many years of getting good at looking at graphs. You guys, not so much. So maybe you're still looking at this graph going, that doesn't make much sense to me, Mr. C. I'm not sure what you mean by it's supposed to make things easier. It does. And you guys will see different examples of graphs, and learning what those shapes mean, learning what the patterns mean, make it so you can sort of take a bunch of shortcuts. I look at this and go, up, down, up, flat, down, up. I immediately know what all those things mean. And I know the slope, remember that word, I know how steep it is or shallow it is, and that tells me important information too. With practice, you guys will be able to do that as well. And don't worry, you're going to get a lot of practice. I can just hear you cheering from here. All right, let's flip over the page and let's see what we can do. Point of fact, given the nature of this purpose of graphing video, maybe what I'll do is I'll cut it here and then we'll do a new video talking about the next page on 33 about slopes. That way it'll be a little easier for people to figure out what's going on as they're watching this stuff later. So, see you guys for the next one.